The International Space Station, ISS, is nearing the end of its extraordinary journey, and the race to build its successor is intensifying. Among the top contenders, SpaceX has unveiled a bold and groundbreaking vision, transforming its iconic Starship spacecraft into a revolutionary new space station. But just how transformative is this concept? Let's dive into today's episode of Rate SpaceX to explore this exciting idea. For the past 24 years, the ISS has been a cornerstone of space exploration and research. However, its retirement looms on the horizon, and when it departs, China's Tiangong station could stand alone as the world's sole operational space station. This scenario would mark a significant setback for the United States in the global space race. To maintain its leadership, NASA is proactively pursuing a successor to the ISS. Through unfunded Space Act agreements and collaborations under the Commercial Space Capabilities Initiative, NASA is working to secure the future of space exploration. As part of this effort, NASA has partnered with 7 U.S. companies to address both commercial and governmental needs for the next generation of space infrastructure. The companies selected for the CCS-C-2 program include Blue Origin, Northrop Grumman Systems Corporation, Sierra Space, Special Aerospace Services, Think Orbital, Vast Space, and of course, SpaceX. Each of these players brings its own innovative approach to shaping the future of space stations. But SpaceX's proposal stands out for its audacity and potential to redefine what's possible in space. Unlike other contenders aiming to build stations from scratch, SpaceX proposes a bold and unconventional solution, using its Starship spacecraft as the foundation for a new space station. Supported by its broader ecosystem, including Super Heavy, Dragon, and Starlink, Starship would serve as a multifunctional low Earth orbit destination, handling crew and cargo transportation, communications, and ground operations. Though unconventional, this concept is not entirely new. Historically, there have been proposals to repurpose components like external fuel tanks into space stations. Upon closer examination, Starship offers several key advantages that make it a promising candidate for this transformation. First, the material. While Starship wasn't specifically designed to be a space station, its stainless steel construction offers notable benefits. Stainless steel is highly durable, resistant to corrosion, and capable of withstanding the harsh conditions of space, such as extreme temperatures and micrometeorite impacts. This resilience not only ensures the spacecraft's integrity during space travel, but also makes it an excellent foundation for a long-term space station. Additionally, stainless steel is relatively easy to maintain and repair compared to other materials used in space infrastructure. Second, size matters. Starship excels with a height of 50 meters, a 9-meter diameter, and an interior volume that already surpasses that of the ISS. Starship is massive. The upcoming Starship V-3 model, standing at 70 meters tall, would expand its capacity even further. Originally designed to carry 100 passengers on multi-day interplanetary missions, Starship is perfectly suited to accommodate living quarters, workspaces, storage, and scientific equipment required for a space station. Another key advantage is reusability. If adapted for use as a station, Starship's ability to return to Earth for refurbishment could dramatically reduce costs over time. This reusability aligns with SpaceX's broader mission to make space travel more economical and sustainable. NASA and SpaceX envision a space station constructed from multiple interconnected starships. This concept involves arranging dozens of starships in a circular configuration to create a rotating wheel station. By rotating about its axis, the station would generate artificial gravity through centrifugal force. Properly calibrated, this could simulate Earth's gravity, addressing the health challenges posed by long-term exposure to microgravity. Even with such groundbreaking features, the Starship space station would be remarkably cost-effective. After 24 years of operation, the ISS has accumulated costs of approximately $150 billion. In comparison, Musk has estimated that each Starship could eventually cost as little as $20 million. By connecting 50 Starships, the total cost for a large-scale space station might only reach $1 billion, just a fraction of the ISS's price tag. With its large capacity and affordability, such a station could pave the way for commercial space tourism. However, transforming Starship into a fully functional space station presents significant technical hurdles. With its large capacity and affordability, such a station could pave the way for commercial space tourism. However, transforming Starship into a fully functional space station presents significant technical hurdles. One major issue is that a substantial portion of Starship's structure, such as its engines and propellant tanks, would be unusable for station purposes. These components, which occupy nearly half of the spacecraft, limit the available living and working space. While some have proposed repurposing the methane storage chamber as additional interior space, such modifications would require extensive structural changes in orbit, posing logistical and engineering challenges. Connectivity is another critical concern. Traditional space stations feature numerous external structures, including solar panels for power generation and docking ports for resupply missions. Starship, designed with a focus on aerodynamics, currently lacks these features. Adding them would necessitate significant design changes, potentially reducing the spacecraft's efficiency as a rocket. Finally, to serve as a long-term orbital outpost, Starship would need upgrades to support permanent habitation, scientific research, and regular resupply operations. Its current design is optimized for exploration and transport rather than sustained orbital presence. Indeed, the potential for the Starship space station is undeniable, even though it has not yet become a reality. With continued innovation, SpaceX could transform space habitation as we know it. For now, Starship is still better suited for its original mission, interplanetary exploration and transport. Nevertheless, as SpaceX continues to push the boundaries of space technology, the prospect of transforming Starship into a remarkable space station remains an exciting possibility. With NASA's backing and SpaceX's proven ability to achieve the seemingly impossible, the dream of a next-generation space station could eventually come to fruition. Until then, the world watches with anticipation as SpaceX forges ahead with its bold plans for the future of space exploration. SpaceX is partnering with a promising player, VAST, to deliver what many believe could be the second generation of the International Space Station. VAST, a privately held aerospace company based in Long Beach, California, is emerging as a significant contender in the race to replace the aging ISS. Founded by Jeffrey Manber, a space industry veteran with experience at organizations like NanoRacks and SpaceX, VAST focuses on creating platforms for research, commercial ventures, and space tourism. Under NASA's second collaborations for commercial space capabilities, VAST is leading the development of two ambitious space station projects, Haven 1 and Haven 2nd Haven 1. The first of these projects is already in development and is intended to serve as both a luxury space station and a platform for scientific research. Scheduled to launch no earlier than August 2025 aboard a SpaceX Falcon 9 rocket, Haven 1 will host its first mission, VAST-1, with a crew of 4 astronauts supported by a Crew Dragon spacecraft for a 30-day stay. Although Haven 1 will rely on the Crew Dragon's life support systems for extended missions, it is not designed for long-term self-sufficiency, limiting its ability to function autonomously for prolonged periods. However, Haven 1 is just the beginning. VAST has grander plans, including the development of Haven 2, a larger, more advanced station that could serve as a potential successor to the ISS. Haven 2 will include the Haven 2 Lab, a cutting-edge facility designed for microgravity research and in-space manufacturing. The station will be significantly larger than Haven 1 and is projected to launch in phases, with the first module expected to launch as early as 2028 aboard a Falcon Heavy rocket. This initial module will feature an additional 5 meters in length and double the usable volume of Haven 1, as well as docking ports at both ends for future expansions. Unlike the ISS, Haven 2 will prioritize astronaut well-being alongside scientific research. The station will feature private living quarters, workspaces, and modern amenities like Starlink connectivity and 2 large domed windows for observing Earth, a key selling point for space tourists. In addition to a focus on crew comfort, Haven 2 will offer a variety of scientific facilities and payloads, with additional modules expected to launch between 2029 and 2030. Each module will be equipped with independent propulsion, life support, and docking systems, ensuring versatility and reliability for long-term missions. In 2030, VAST plans to launch a core module with a diameter of 7 meters. This module will include essential systems such as an airlock for extravehicular activities, EVAs, docking ports, and a robotic arm. Once operational, the core module will serve as the central hub for the station, allowing for further expansion and the addition of 4 more modules by 2031 and 2032. By this time, Haven 2 will surpass the ISS in size and capability, setting a new standard for space stations. One of VAST's unique advantages is its potential to attract private citizens and space tourists. Unlike government-funded space stations, Haven 2 could serve as a platform for luxury space vacations and private missions. By targeting the growing space tourism market, VAST aims to offer a more accessible and commercially viable alternative to traditional research-focused stations like the ISS. To bring this vision to life, VAST is heavily reliant on its partnership with SpaceX. SpaceX's Falcon 9 will be used to launch Haven 1, while Falcon Heavy will handle the heavier modules of Haven 2. In the future, VAST also plans to use SpaceX's Starship for core module launches. Additionally, Starlink connectivity, which will be integrated into both stations, will be provided by SpaceX, ensuring reliable communications and data transfer for crew and research operations. SpaceX's proven technology and cost-effective solutions make it the perfect partner for VAST's ambitious plans. VAST CEO Max Hayat has highlighted the importance of their collaboration with SpaceX, stating, "We're trying to be as close as possible as partners, as much as they'll allow us." This partnership is mutually beneficial. VAST gains access to SpaceX's unparalleled expertise and proven capabilities, while SpaceX explores the potential to integrate its own space station concepts into VAST projects, further solidifying its long-term vision for space habitation. As the race to succeed the ISS intensifies, private companies are competing to lead the next chapter of space exploration. While the final outcome remains uncertain, one thing is clear: the new wave of space stations, including VAST's Haven 1 and 2, will redefine what we think is possible. Combining commercial appeal, cutting-edge technology, and a commitment to sustainability, these stations have the potential to transform space exploration and make it more accessible than ever before. Well, folks, that's it for today's episode. Thank you for tuning in. As always, this has been Kevin from Great SpaceX. Until next time, keep looking up.